Hello everyone, we are now on module 5, which is retaining walls. So before we discuss the concept and principles of retaining walls, let us try to identify the learning outcomes for this chapter. So at the end of this module, the students are expected to identify the different types of retaining wall, identify the procedure for determining the stability of the retaining wall, learn the concept of proportioning for the stability of the retaining wall, and check the stability of the retaining wall. So basically, when you talk about retaining wall, those are structures designed to restrain soil to a slope that it would not naturally keep to typically a steep or near vertical slope. So the purpose of retaining wall is to restrain the movement of the soil, and these are often found in places where extra support is needed, so to prevent the earth from moving downhill the area. So these retaining wall are relatively rigid walls used for supporting soil laterally so that it can be retained at the different levels on the two sides. So in other words, retaining walls serve basically as a protection for near vertical sloping areas or sloping areas to prevent the soil from somehow erosion. So that's the main purpose of retaining wall. So there are two categories of retaining wall. You have the conventional retaining wall and mechanically stabilized earth wall. So when you talk about retaining wall, so for this chapter, we're going to discuss the conventional retaining wall. Mechanically stabilized earth walls, those are uh, retaining walls that make use of some of the uh, reinforcement such as geosynthetic that is applied on the soil to prevent the uh, movement of the soil from being eroded. So now in this chapter, we'll focus on conventional retaining walls. So conventional retaining walls can generally be classified into four varieties. So we have the gravity retaining walls. You have the semi-gravity retaining walls. We have the cantilever retaining walls and counterfort retaining walls. So basically, for this conventional retaining walls, you have this illustration for the gravity wall, which is shown in this figure. These are constructed with plain concrete or stone masonry. They depend for stability on their own weight and any soil resisting on the masonry. The type of construction is not economical for high walls. So this is basically the illustration for a gravity wall. Then we have our semi-gravity wall. When we talk about a semi-gravity wall, in many cases actually, a small amount of steel may be used for the construction of gravity wall. So thereby minimizing the size of the wall section. So such walls are generally now called as semi-gravity wall. Then we have the cantilever wall. So this is a cantilever wall, are made of reinforced concrete that consists of a thin stem and a base slab. This type of wall is economical to a height of about 8 meters. Then we have here the last one, which is the counterfort retaining walls. These walls are similar to cantilever wall. At regular interval, however, they have thin vertical concrete slab known as counterforts. So we have here the counterfort. These are vertical concrete slab that tie the wall and the base slab together. So this counterfort, it ties the wall, this wall, and the base slab. The purpose of the counterfort is to reduce the shear and the bending moments. So those are basically the conventional retaining walls that was classified into 4 categories. To design a retaining wall properly, an engineer must know the basic parameters. So what are those parameters? We're talking about the parameters unit weight, angle of friction, and cohesion. So basically, those parameters are necessary to design a retaining wall. So there can be 2 basic parameters. One parameter which includes unit weight, angle of friction, and cohesion. One, this can be situated or located on the soil retained behind the wall, and the other basic parameters is located on the soil below the base slab. So once we know the properties of the soil behind the wall, so the engineer would be able to determine the lateral pressure distribution that has to be designed for. Of course, a retaining wall, there would be the forces that will be acting is due to the lateral earth pressure, because they are the retaining wall supports the soil. So basically, the forces that will be acting on that retaining wall are the lateral earth pressure. So it is necessary to determine the lateral pressure distribution that has to be designed for. So there are 2 phases in the design of the conventional retaining wall. First, with the lateral earth pressure known, the structure as a whole is checked for stability. The structure is examined for possible overturning, sliding, and bearing capacity failures. The second one, each component of the structure is checked for strength. The steel reinforcement of each component is determined. So basically for this, in this chapter for retaining wall, we are after on the checking for the stability of the retaining wall. So we're going to check the stability of the structure based on, in terms of overturning, sliding, and bearing capacity failure. As we recall from your previous discussion, specifically on fluid mechanics, you encountered already about the analysis of dam. So basically, the concept there that you applied is similar to the concept that you're going to apply in the computation for the factor of safety against overturning and against sliding. In dams, in fluid mechanics, you just cover checking for overturning and sliding. However, in foundation engineering, you're going to have an additional. So you're going to check the stability. Aside from overturning and sliding, you're going to check for bearing capacity failures. So some retaining walls have their backfill stabilized mechanically by including reinforcing elements such as metal strip, bars, welded wires, geotextile, and geogrid. So basically, if there is now an introduction, if there is an inclusion rather of metal strip, there is an inclusion of wire mats, geotextile, that is a retaining wall wherein there is the soil was mechanically stabilized. So aside from the retaining wall, the soil was stabilized through geotextile, wire mats, so those geogrids, so that is basically being termed as mechanically stabilized soil. So it would prevent also from displacement without much damage. So gravity and cantilever walls. So for gravity and cantilever walls, we're going to have what we call proportioning retaining walls. So in designing retaining wall, an engineer must assume some of their dimensions. And the assumption of that particular dimension of the retaining wall, either gravity or cantilever wall, is what we call proportioning. So in proportioning, such assumption allow the engineer to check trial section of the wall for stability. If the stability check yield undesirable result, the section can be changed for recheck. The general proportion of various retaining wall components can be used for initial checking. So this one is an illustration for, this is a figure which illustrates the different dimension that is suggested for the proportioning of retaining walls. So this is for this figure is for gravity wall, and this one is a cantilever wall. So we have here the suggested dimension for the gravity wall and the cantilever wall. So basically, this is what we call, we're going to have, this one is an assumption. We're going to have an assumption of the dimensions of the gravity wall and the cantilever wall. And that assumption is what we call proportioning. And through assumption, you can check through you can check by trial section of the wall stability. So basically, if once you have computed, once you have checked the factor of safety against, you wanted to check against sliding, overturning, and bearing capacity failure. If it doesn't satisfy the minimum requirement, basically in terms of factor of safety, which is you have to introduce again, or you're going to change the dimension of your retaining wall and then recompute again and checking for the stability against overturning, sliding, and bearing capacity failure. So we have to take note that the top of the stem of any retaining wall should not be less than 0.3 meters. So the top of our retaining wall should not be less than 0.3 meters for proper placement of concrete, and the depth D to the bottom of the base, this D to the bottom of the base should be a minimum of 0.6. However, the bottom of the base slab should be positioned below the seasonal frost line. So for our counterfort retaining wall, the general proportion of the stem and the base slab is the same for cantilever walls. So basically, cantilever and counterfort wall would have the same general proportion for the stem and the base slab. So, however, the counterfort slab may be about 0.3 meters thick and spaced at the center to center distances of 0.3 h to 0.7 of h. So,